Guys, today we're going to explain about the inheritance of autosomal recessive disease. We're going to talk about one of autosomal recessive diseases, which is galactosemia. Let's first talk a little bit about this disease and its symptoms. As you can see in the second slide, when any normal individual consumes dairy products that are rich in lactose, which is the sugar that's found in milk, this lactose, and under the effect of lactase enzyme, it's chemically transformed or hydrolyzed into glucose and galactose. Glucose is used by our body cells as a source of energy, and galactose usually is in normal conditions and in normal individuals, it is transformed into glucose by GALT enzyme, and this transformed glucose will then be used as a source of energy. Now, what happens in individuals having galactosemia? Patients having galactosemia, they start consuming dairy products. Usually they are infants, لأنه symptoms they appear at infancy. So the infants start to breastfeed, for example, or if their mothers, if the infants are given milk formulas. So once they consume milk after birth, the lactose, which is the milk sugar, is chemically hydrolyzed under the effect of lactase into glucose and galactose. Glucose is used as a source of energy for our body, and in those individuals, they have a mutated GALT enzyme or a non-functional GALT enzyme. This problem is due to a mutation in a gene located on an autosome. So galactose will build up, and this will lead to serious health problems. What are these healthy problems? Infants having galactosemia, they have a brain damage due to the accumulation of galactose, they have cataracts on eyes, jaundice, they have enlarged liver, and they suffer from the damage of their kidneys. So because of that, their fate is the death if remain untreated. Now we're going to solve an exercise about the diagnosis of galactosemia. So galactosemia is a genetic disease located on an autosome, which results from a deficiency in the enzyme transforming galactose into glucose. Several days following the consumption of milk or milk products, the following clinical signs appear: vomiting, diarrhea. On the long term, infants would show retarded growth, and later they may have mental retardation. As you can see in document 1, we have a family. You can see 5 members in this family are affected by galactosemia, and here we have a couple, Mrs. G and Mr. G. They are expecting a child. So member 5 or member 4-5 is the expected baby. They are worrying if their coming baby is going to be affected by galactosemia. The first question is to indicate if the allele responsible for the disease is dominant or recessive, and to justify your answer. When we're asked to determine if a certain allele coding for a disease is dominant or recessive, always search for 2 normal parents or normal couple who give birth to affected child or children. We can choose any member in the family. For example, we can use 1-1 and 1-2, 2-1 and 2-2, 2-4 and 2-5, 3-3 and 3-4. So all these mentioned couples, they are normal. They are both normal, and they gave birth to diseased children or child. So this is a hint that the disease is coded by a recessive allele. How can I write a proper reasoning? You have to say, since, choose any couple. So since members 1-1 and 1-2 are normal, and they gave birth to diseased children, mention the children, 2-3 and 2-6, then those parents, they are carriers, they carry the diseased allele or the allele coding for galactosemia, which is recessive and which is masked by the dominant normal allele. So here is the answer of part 1. Now, what is very important now is how can we determine the localization of the gene coding for this disease? What do you mean by the localization of a gene? Usually, any gene which code for a certain trait or which is at the origin of which is the recipe which is at the origin of production of a certain protein, which in turn leads to the appearance of a certain phenotype. So any gene can either be located, as you can see in the karyotype, any gene, it can be either located on one of the autosomes from chromosome 1 till 22 or on gonosomes, which are two homologous X chromosomes in females and two non-homologous X and Y chromosomes in males. To determine the localization, نحن just in the case of recessive cases, look for the gender of affected members. So remember, just in the case of recessive cases. Here, when I look at the gender of affected members, I can see that males and females are both affected by galactosemia. We have 2 females that are diseased, which are colored by black. We have 3 males that are affected by galactosemia and also which are colored by black. So also this is a hint that the gene is coded or is found on an autosome. So it's found on one of the chromosomes from 1 till 22. How can I write a proper reasoning? Now, to prove that a gene is found on an autosome, I have to deny 3 cases. So I have to deny that that gene is not found on the non-homologous segment of X. I have to deny that the gene is not found on the homologous segment of X and Y. And also I have to deny that the gene is found on the non-homologous segment of chromosome Y, which is the Hollandric part. Then I can say, therefore, I can conclude that the gene is found on an autosome. The easiest case is to deny that the gene is found on the non-homologous segment of Y. لأنه this segment, which is the non-homologous segment of Y, this segment is found only in males. So if a gene is found here on this part, which is the non-homologous segment of Y, any normal father would have a genotype X, Y. On Y we have capital N. This father would inherit Y capital N to all his sons, who should be normal. But, for example, in case 2, 6 is diseased. So I can say that if the gene is located on the non-homologous part of Y, which is the Hollandric part, the normal father having a genotype XY capital N would transmit Y capital N to all his sons, who should be normal, but his son 2,6 is diseased, so it's not the case. So we denied the first case. Then I should deny that the gene is not found on the non-homologous segment of X. So to prove that the gene is not found on the non-homologous part of X, always in recessive cases, choose a diseased female. What diseased female should have a normal father. Okay, so I can choose 2, 3. I can say that if 2, 3 is, if the gene is found on the non-homologous segment of X, then 2, 3 would have a genotype X small d, X small d. So she would have inherited X small d from her father, whose genotype is X small d, Y, who should be diseased. But her father, 1, 2 is normal, so it is not the case. Similarly, choose any diseased daughter having a normal son. For example, 3, 2 is a diseased daughter. If the gene is found on the non-homologous segment of X, يعني 3, 2 would have a genotype X small d, X small d. يعني this female would have inherited X small d from her father, اللي هو 2, 2 with the genotype X small dy, اللي هو should be diseased but he's normal, so it is not the case. I still have to eliminate or to deny the gene is not found on the homologous segment of X and Y. Here, look for a diseased daughter and son who have normal parents. I can look for 2, 3 and 2, 6. I can say if the gene is found on the homologous segment of X and Y, then 2, 3 would have a genotype X small d, X small d. With 2, 6 كمان, he would have a genotype X small d, Y small d. So because of that, their parents should be diseased. لأنه their mother should be XD, XD, or their father should be XD, YD. But their parents are normal, so it's not the case. So I have to deny the 3 cases. بيكون في كوارتل على كل كيس، على كل denying، to end your answer at the end by therefore the gene is located on an autosome. هل now I have proved that the allele of the disease is recessive. Also I have proved that it's found on an autosome. So now I can write the accurate or the possible genotypes of some family members. We're asked in part 3 to specify the possible genotypes of Mrs. G. بنروح على Mrs. G. She's waiting a baby. I go back to her parents. Her parents are normal, but they gave birth to a diseased son. So parents اللي هن 24 and 25 are both capital N small d and capital N small d. So Mrs. G would have inherited capital N from the first parent and capital N from the second, or capital N from the first parent and small d from the second. So Mrs. G may have two possible genotypes اللي هن capital N or capital N small d. What about member 44? 44 is a diseased male, and the disease is coded by a recessive allele. And what you should always remember إنه the recessive alleles, they do not appear in the phenotype, they are not expressed in the phenotype unless the genotype is pure. So this member to be diseased, he should have a genotype small d, small d. Now the last question is how to calculate the risk. They said in this slide, worldwide, the probability of individuals to be heterozygous for the gene responsible for this disease is 1/100. So in this population, for any individual to be capital N small d, there is a risk which is equal 1/100. Part 4, we're asked to determine the risk for the expected child 4-5 to be diseased. How can I calculate the risk for 4-5? When calculating the risk, always start by asking yourself a question. Can I write the accurate genotype for the parents? So I'm asked to calculate the risk for member 4-5. Can I write the accurate genotype of Mrs. G and Mr. G who are parents for this member? For Mrs. G, as we said later, this female have two possible genotypes. Also Mr. G, we do not have any family history. Okay, so we cannot know we are not able to know his family history. So كمان Mr. G has two possible genotypes. When we have two possible genotypes for the parents, we have to work on a rule which states that the risk for 4-5 to be diseased هي risk for mother to be hybrid, يعني to be capital N small d, and risk for the father to be hybrid or capital N small d times risk for fetus 4-5 to be dd. So who is to be diseased, you should have a genotype small d, small d. What's the risk for the mother to be hybrid? For the mother, her parents are 24 and 25. I am sure about their genotypes. يعني 24 و 25 they are both capital N small d لأنه they gave birth to a child DD who is diseased, they are normal, so they are carriers. So I can put the table of a cross for 24 and 25. So these are the possible genotypes of their descendants or offsprings. Their daughter اللي هي Mrs. G هي normal phenotypically. So as you can see here we have 4 cases. 3 out of 4 اللي هن they are circled by black هن different cases for Mrs. G لأنه she's normal. So out of 3. طيب what's the risk to be hybrid out of 3? We have 2 cases اللي هن ND. So the risk for the mother to be hybrid is 2/3 times what's the risk of the father to be hybrid? So risk للfather, the father has no family history, so I have to use the statistical results which is 1/100. And what's the risk for the fetus to be DD? For the fetus أنا هون اعتبرت إنه Mr. G و Mrs. G they are hybrid ND. So كمان I have to read the table of cross. From the results of the table of cross, what's the risk for this couple to have a child who is diseased or have a genotype small d, it's 1/4. So the answer is 2/3 times 1/100 times 1/4 نطلع بريسك which is equal to 106 1/600. So you have to write the rule Since the verb is determined, you have to write the reasoning behind writing each number. So you have to prove why did you write that the risk for the mother to be hybrid is 2 over 3, and why the risk for the father to be hybrid is 1 over 100. Or also you have to write the reasoning why the risk for 4, 5 to be DD is also 1 over 4 to end up by an answer. So here is the answer of part 4. Now what about part 5? The part 5 we're asked to determine the risk for 2, 1 and 2, 2 to have affected child. 2, 1 and 2, 2. 2, 1 and 2, 2 they are both normal. So أكيد each one of those members should carry capital N allele. Since they gave birth to diseased child يعني هن they are both capital N small d, capital N small d. So here in this case, I am able to write the accurate genotypes of the parents. So no need for the rule. I can simply write the table of cross for those members. For 2, 4 and 2, 5. 2, 1 and 2, 2. So here is the table of cross for 2, 1 and 2, 2. Any hybrid parent having capital N small d alleles, half of his gametes or her gametes would contain capital N allele, or the other half would contain small d allele. By writing the results of the offsprings, we can see clearly that there is a risk which is equal 1 over 4 for this child to be DD. Also, since the verb is determined, then start your answer by writing the genotype of the parents and write the reasoning behind your answers, and then write the table of cross. لأنه the verb is determined, you have to verify, you have to write a reasoning for your answer to end up by the risk.